Okay, so let's take some time to just review what we've talked about with factoring. When you're given an expression that is simplified and that you're asked to rewrite that expression in its factored form, what you're what you're being asked to do is rewriting the expression as a multiplication problem. Okay, kind of doing the opposite of distributing. Okay, so the very first thing you always want to look at is asking yourself if there's a greatest common factor that you can divide evenly into all of the terms. Okay. So that should always be your go to. After that, you're going to want to see if there's any other way to factor. And we've got 4 different techniques that we're going to be learning. And so, depending on how many terms, okay, how many terms are in your expression that you want to factor, that's going to determine which technique you use, okay? So we looked at what happens if there was 2 terms, okay? Now, if there's 2 terms, it's very restrictive to being able to factor that. You have to have a subtraction and that both terms have to be perfect squares, okay? Then we've looked at a method now where if there's 3 terms, okay? So we've got 2 different methods when we have 3 terms. One of them is a shortcut method, I like to say, and that's going to be when you have a trinomial, okay? Trinomial just is a polynomial that has 3 terms, where your leading coefficient is a 1. That means that the coefficient in front of your x squared is just 1, okay? And so you get to do that kind of shortcut method. Let's look at a couple of the examples. Here on the x squared minus x minus 42, since this is a trinomial, okay, it has 3 terms. The leading coefficient is a 1, okay? I can use this shortcut method. So I need to find, okay, it's going to be able to be factored into 2 binomials, okay, where your first term will be an x, okay? And then the other 2 integers in your binomial will be found by asking yourself, what are 2 numbers that multiply together to give you negative 42 and add together to give you, ooh, this is a tricky one. Says negative x. What's your coefficient? It's a negative 1, okay? So you need these to multiply together to give you negative 42 and add together to give you negative 1. Well, let's think. 42, we have negative 42. You can have 7 times negative 6. You could also have negative 7 times positive 6. There's the list could go longer, but I think that I found one. Negative 7 times positive 6, that's negative 42. And then negative 7 plus 6 is a negative 1. So those are going to be my 2 integers that I plug into by my binomials. Negative 7, positive 6. So the factored form is the quantity x minus 7 times the quantity x plus 6. All right, so for our next example, they have it so that we have a trinomial, okay? And let's think about what our first step should always be, okay, when we're factoring. Our first step should always be, hey, is there a greatest common factor? And I'm looking here, and it looks like there's a 2 that I could divide evenly into all 3 of my terms. So I'm going to pull that 2 out, and what am I going to be left with? I'm going to be left with the w squared plus 10 plus 25. Okay, now we began the factoring, but we're not completely factored. What's left inside my parentheses is a trinomial that has a leading coefficient of 1. So I know that it's going to be able to be factored. So let's go ahead and set up my parentheses. I still have my 2. That factor is not going to go away. And then I'll have 2 binomials where the first term will be w. All right, my integers for the second term will be found by asking ourselves, I need 2 numbers that multiply together to give me positive 25 and add together to give me 10. And I just realized I forgot 10w. Sorry about that. So what are my 2 numbers? Well, 5 and 5, right? 5 times 5 equals 25, and 5 plus 5 equals 10. So that is my factored form. Okay, so now today we're going to explore a new technique, okay? And it's still going to be factoring trinomials, okay? But this time there's going to be a coefficient in front of my x squared terms, which is going to make this a little bit more work, okay? And so there's lots of different techniques to being able to do this. So if you explore some on YouTube, you'll see instructors doing it all different ways. I've chosen a way that's called the X method, and you'll see that in the next video.